Okay, let's wrap this learning target up. Okay, so now the goalpost method doesn't always just have one single post. There is very often more than that. So let's give you an example. It is 83.2 kilometers to Cedar City from St. George. How many centimeters is it? Okay, so when I have my goalpost, I have my 83.2 kilometers. And I'm going to put kilometers on the bottom so that it cancels. And normally I'd put centimeters on top because that's my desired. But you see, if this was centimeters, I don't know that conversion factor. That's not in my list that I had to memorize. But I do know kilometers to meters and meters to centimeters. So when you run into this issue where you kind of have this like double prefix, you're going from one with a prefix to another one with a prefix, and you're not sure what that conversion factor is, take it to the base unit, which in this case is meters. Okay, so I'm going to go from kilometers to meters, and then from meters to centimeters. Add those conversion factors. 1 kilometer contains 1,000 meters, and 1 meter contains 100 centimeters. And let's see if we do end with those desired units of centimeters. So kilometers is on the top and the bottom, so those units will cancel. Meters is on the top and bottom, so that'll cancel, and I'm left with just centimeters on the top of my fraction. That's exactly what I want. So this result here, I'm going to have 83.2 times by 1,000 times by 100 with units of centimeter. And then it's going to be divided by 1 times by 1, so 1. Okay, so this will equal 83.2 times 10 to the 6th centimeters. Okay, let's add one here. So let's go notes from the board discussion. Let's add something here. I want you to try this first on your own, then come back to the video and see how you did. Okay? What if I want to know how many seconds there are in 2 days? I want to know how many seconds are part of 2 days. Okay? So let me get you started. We're going to lay out our goalposts. We have 2 days that we're starting with. We're going to put day on the bottom so that it cancels. But then what conversion factors are we going to need to get to seconds? Okay, so hit pause, give that a go, and then come back and see how you did. Okay, so I can go from days to hours, but I don't know how many days are in a second. But I do know how many minutes are in an hour. And I also know how many seconds are in a minute. Okay? So I know that 1 day has 24 hours, and that 1 hour contains 60 minutes, and that 1 minute contains 60 seconds. And let's see if our units cancel and we do end with seconds. So days cancel, hours cancel, minutes cancel, and I am left with seconds. Okay, so on the top of my fraction here, I'm going to take 2 times by 24 times by 60 times by 60. And I get 172,800. Okay, and units of seconds divided by 1 times by 1 times by 1. So anything divided by 1 is itself. So that's how many seconds there are in 2 days. Think of this longer goalpost as, okay, I know that this is where I'm starting, and I know I need to end in centimeters, or I know I'm starting at days and I need to end in seconds. what path can I take to get there where my units all cancel and I'm left with those desired units? Okay. A box has a dimension of 24.5 centimeters, 36.5 centimeters, and 15 millimeters. What is the volume of the box? Let's start by converting their value here from millimeters to centimeters so that we're all in centimeters. So we have 15 millimeters. I want to know what that is in centimeters, and one of those conversion factors that I've memorized is that 1 centimeter contains 10 millimeters. So then I'm going to have 15 centimeters divided by 10, or 1.5 centimeters. Now I'm going to take that 24.5 centimeter, multiply that by 36.5, and lastly that'll be multiplied by the 1.5 centimeter. So I'll plug that in my calculator. Oh, I added them. Let's multiply. Base times by width times by height. So we're figuring out a volume here. So I get 1,341.38. Okay. And what are my units? Well, I'm taking centimeters multiplied by centimeters multiplied by centimeters. So my final units here are not just centimeters, they're centimeters cubed. Now, what if I asked you how much that is in millimeters? Well, again, something that we gotta have, that we gotta know for our exam, is cubic centimeters is exactly the same as millimeters. Sorry, millimeters, milliliters. Okay. All right, last part of this is percent error. Now, do you remember when we were talking in class about the scale and we were measuring the 500-gram weight? So here was the idea. We have this weight. On the bottom of it, it says it's 500 grams. So we know that this mass weighs 500 grams. And we place it on a scale. Okay? And let's say that that scale reads it as 502 grams. Okay? So that would be my measured number. That's what the scale gave me. Even though we know that our theoretical or our accepted number was 500 grams. Okay? Now, obviously there's an error between the two, but how big is that error? And that's what we're going to look at here. So first thing, percent error is equal to this idea of error in absolute values divided by the accepted times by 100. Okay? So I'm going to rewrite this. I'm going to say percent error is equal to the absolute value of my experimental value minus my accepted or actual value. Okay, that's in absolute value marks, right? And then that'll be divided by the accepted. And then we will times by 100. Okay? So with our numbers that we had above, the experimental was our measured, which is 502 grams, and we're going to minus that from the accepted, which is 500 grams. Okay? And we'll divide that by the accepted, which is 500 grams. And then finally we'll multiply by 100. Okay, so when I do this, I'm going to take that measured value, okay, and I'm going to minus it from the accepted. So that's what's on top of my fraction. It's not a negative, but if it was, it's an absolute value. So we would change it to a positive. And then we're going to take that and we're going to divide it by the actual, which is 500. Okay. And then the last step here was multiplying that value by 100. And that's my percentage, 0.4. The error here was so small. In fact, the percent error between those two values was only 0.4%. So it wasn't even 1% error. Okay. We are discussing mass and volume with density in the lab, and so that's where that information will be. Make sure if you're unable to attend class that you watched the video for the lab in the day just beyond this, and that you fill it out and that you're understanding all that information. All right, guys. Well, we are wrapping up Unit 1. So make sure you read through all your notes, you're feeling confident about it. And if you're not so sure, sign up for a study session so we can talk through anything you're struggling with before you take the exam.